research and discovery. Futurists.
Cities are the beating hearts of the modern world. Powerful magnets for millions of people, hungry consumers of energy. And they're expanding.
Cities today are growing worldwide. I mean, more than half of the population already lives in cities. In Europe, it's even more. It's nearly 2/3 of the people that live in cities, and this trend is going to continue.
Such constant growth puts a high demand on resources.
In cities, we need energy for buildings, providing heat and cold and electricity, and also 1/3 of the energy is needed for transport. And this is a big challenge because, especially in transport, most of the energy comes from fossil fuels.
The question of energy applies to all aspects of city life. Where that energy is from and how it's managed will be a defining factor in the future.
As far as buildings are concerned, our main challenge in the future will be rehabilitation. For new buildings, the challenge is there, but much easier because we have very good building standards now in every European country, and we have the technologies to reduce consumption to nearly zero.
Cutting energy bills is a key theme for the Canyon Center in Istanbul. Some may come here for retail therapy, others to study building physics. Zerrin Yilmaz is leading a survey of energy consumption here as part of a European Union research project.
You have to find the best solution during the design stage, and you have to test different design scenarios of the building to find the best solution for energy efficiency. If you can find the best solution, there is 50% energy saving possibility for these kinds of buildings, and it's a huge amount because they are consuming a lot of electricity and natural gas for heating, cooling, lighting, and so on.
At this wind tunnel in the Istanbul Technical University, a model of the Canyon complex sits center stage. The smoke shows how air flows between the buildings, and the model office tower is covered in tiny pressure sensors.
Pressure distribution is important if we think about the ventilation of the building. On the windward side we have positive pressure, on the backward side we have negative pressure. This pressure difference of the two sides makes the air flow through the building, which might be useful for ventilation issues or also for cooling the building.
Zerrin's team has been working closely with building managers at Canyon. The university's modelling has already helped them use their lighting more efficiently. More changes are likely to be proposed.
Now we are looking for the possibility of the energy saving through natural ventilation mostly. And also we have other research studies on this building for energy efficiency. For example, photovoltaic applications for electricity production from sun, and better shading devices for cooling energy saving, and also some parametric studies to see the relation between energy consumption and comfort.
This bright white dome is a vital tool for studying cityscapes. Known as the artificial sky, it gives scientists a global view of an urban landscape.
Very quickly you can see how every building surface is
The intricate array of bulbs and glowing surfaces allows researchers here at Ursula Reicher's home university to follow how sunlight changes over the course of a day.
The sky's never equally bright. You usually have brighter patches just around the sun, the horizon is brighter, and we have to be able to recreate that situation realistically, to be able to say that there is enough light on a building.
In the basement of the university lie the blazing lights of an artificial sun. This is another important device for researching healthy, low-energy office buildings.
Here we have a simulated sun. We project light onto a facade system, and behind that there is a real office room which we can cool down. We can see exactly how much energy comes into the room through the facade system. Thus we can get very precise coefficients of facades and then tell property developers, okay, the way this facade is built lets 70% of the sun's rays through, and it has got this and that thermal characteristics.
Transport is a major challenge in cities because it's today mainly based on fossil fuels. We can replace these fossil fuels with electricity or hydrogen-based technologies. We will need a lot of infrastructure for either of the systems, and we need to provide the green energy to these systems. So there needs to be a huge amount of solar, wind, biomass, electricity generation or hydrogen generation, which we then can use for transport.
This workshop in central Spain is an Aladdin's cave of new transport technology. The engineers are testing hydrogen in real-life applications across all kinds of machines. This wheelchair has a battery and fuel cell beneath the seat and a bottle of hydrogen on the back.
Basically, there are three major benefits with this wheelchair. Greater autonomy, better than with conventional electrical wheelchairs. Shorter recharging time. With conventional electrical wheelchairs, it takes up to 8 to 10 hours to recharge. With this chair, it's operative in 5 minutes, and its lighter weight makes it easier to transport.
Using these fuel cell vehicles on a daily basis is part of a wider European initiative to explore how hydrogen fits into city life. At the moment, the main downside is that hydrogen is generally extracted from fossil fuels, and the process is expensive. The advantage is that hydrogen technology is clean at the point of use. The only thing coming out of the exhaust pipes here is water. For city centres, it's ideal.
These vehicles have a range of about 100 to 120 kilometers, and the maximum speed is about 50 kilometers an hour, because these kinds of vehicles are used within cities, not to travel between them.
No new technology is complete without it being tested by the end user. And in the case of this hydrogen wheelchair, that's retired farmer Francisco Muñoz Tierno.
It'll be a nice gizmo. Useful gadget for people like me. It'll be very useful because I can't walk. And now with this I can get around as far as maybe... What's the range for this? 1 kilometer? 2 kilometers? More? 40 kilometers? That's fantastic, folks.
There's also a drive to rethink urban transport, not only in terms of fuel, but also safety, application and ease of use. This cute buggy uses lasers, movement sensors and intelligent speed adapters. The vehicle can find its way and run at slow speeds in an autonomous way.
Here you are in a saiba car. It's a vehicle that you could take from a station or even call it to your home and it would come on its own. You get into the car, you select your destination on the screen and the vehicle takes you there. There's a front-wheel drive motor, electric braking, electric steering, and it's driven by the computers.
The Cybercar is one of a series being developed under the EU CityMobile project at this lab in Paris. Building a level of autonomy into vehicles is seen as a key way to make them safer as well as easier to use. Olivier Garcia-Favreau is working to optimize the laser system.
You have a mirror that rotates and a laser beam that fires into the mirror. The laser's direction changes according to the position of the mirror. And from that information, the obstacles or the absence of obstacles, that means open space, and moving obstacles, you have all the information that you need to then follow a path and avoid pedestrians and cars.
Olivier's job is to push laser mapping to the limit. His system is integrated with a full suite of cameras, inertia sensors and a GPS navigator. The idea is that just about anyone could use the vehicle to follow a predetermined route around a city.
So we follow a path that we've defined on Google Earth. And the vehicle does it all on its own. The only thing is that you push on a lever to put it into automatic mode. And when you let it go, it stops.
In cities we need to use the urban fabric to produce our energy. That is mainly the buildings. So I think one big part is going to be solar, because it can be so easily and nicely integrated into buildings. And then, on the other hand, we will still need centralized power plants, best in cogeneration mode, so to produce electricity and heat, and if possible, cold. And then we need networks to distribute that energy.
A winter's day at Scharnhauser Park on the outskirts of Stuttgart. It's cold and the biomass plant is working to full capacity.
This plant uses a combined process to produce eco-friendly heating and electricity for the residential area.
The
energy source is biomass, which means regionally sourced waste wood from landscaping. The power plant uses around 200 cubic meters of this material per day. In so doing, it satisfies 80% of the yearly demand of the area, so that means 10,000 people, and at the same time the power plant produces electricity for 5,000 households.
In winter, 4 trucks a day bring cuttings from city parks and highways. In summer, the excess heat is used to power cooling machines in local office buildings.
The energy efficiency of this plant is particularly high because the whole heat production is used, and we reach an efficiency ratio of 89% with this facility.
Down the line in Lyon lies the Confluence, one of the largest city centre regeneration sites in Europe. As this old industrial zone is reborn, so new sources of energy are introduced. In many basements lie small wood chip biomass plants. And all across the Confluence are solar panels.
A photovoltaic panel is a device that transforms the light of the sun into electricity. These panels are normally made using silicon. These are semiconductor elements made from silicon that have the physical property of being able to transform photons of light into an electric current.
As part of Europe's Renaissance project, Bruno Guédon and his colleague Mark Jedlicka advised property developers here on how to best exploit the power of the sun's rays in a city environment.
We identified the potentials, we measured the surface that was available, we tried to help the constructors, the promoters, the architects for these buildings, so that they could put the biggest possible surface area of photovoltaics on their buildings.
The rooftop and south side of this office block are literally covered in photovoltaic panels. The architect's aim is that over the course of a year, this building should be able to produce at least as much electricity as it consumes. But the design takes solar power one step further, as here on the facade, the panels are an integral part of the building.
In the case of this building, the photovoltaic panels have a double function. A function to produce electricity, that's why they're there, but also you can see from how they're aligned, they serve as sunshades. They shade the floor below, and that means in summer, when the sun is very high, the windows below receive less sunlight than if the panels weren't there, so they're able to reduce the demand for air conditioning.
It's no accident that photovoltaic panels are so prevalent here in this part of southeastern France. The local government required that developers produce electricity from renewable sources on site. Their choices were limited. Photovoltaic panels may have a high initial investment cost, but in other respects, they're a perfect fit for building managers.
The special characteristic of photovoltaic is that it produces energy without any moving parts, without any emissions whatsoever, contrary to all other ways of producing electrical energy which use rotating machines, which need maintenance of the mechanisms, and which generate noise. Here we have electricity being produced without any moving parts, so without any noise.
So people start to get more aware, and even investors start to get more aware that if they construct today, they will have to pay very high prices for energy in the next decades. So energy will become more and more of an issue. And as far as public bodies or municipalities are concerned, they now start to develop guidelines for their own developments, which very often involve green ideas.
The fresh tarmac of the Parc de l'Alba on the outskirts of Barcelona. Here, many of the key trends in urban planning come together in one place. Ursula Eicher and local engineer Carlos de Pena have joined forces under a European Union research initiative to integrate the energy supply and consumption systems on site.
More than new technologies, what we've sought is new applications of existing technologies. In that sense, the improvement in thermal isolation, for example, which is obligatory in our regulations, will really reduce the demand for energy. We're also aiming to have road traffic and pedestrian traffic live happily side by side. With that in mind, we're promoting the use of public transport with the construction of a new intermodal station and the use of bicycles by constructing bike paths on absolutely every street.
As cities grow, apartment blocks are built one after another. This is the first of many in the Parc de l'Alba development. And as architect Nuria Pedrals explains, it has some innovative features.
Here you have this panel, which we have put in all the apartments for the residents, which explains the different positive features that there are in the flat and how to use them. Here we have a diagram, for example, for the cross ventilation, and of how they have to manage the windows in the winter and in the summer to get the most benefit from it.
A total of 3,500 apartments like this will be built, a third of them low-rent social housing.
Mira, esto es muro trombe. This is a trombe wall, all of these distinctively colored pieces. It's an old technology, as you know, which stores heat in the winter and then translates it to the interior of the flat. And in contrast, in summer, with this system of grills, it then forms a ventilated chamber and stops the heat passing from the outside to the inside.
At the heart of the Parc de l'Alba will be 4 plants generating electricity while also powering heating and cooling systems. They'll use a mix of natural gas, biomass and solar thermal energy. Again, the watchword is efficiency.
The energy that we produce is going to be used for the following things. On one hand, the electricity will be injected into the grid, and on the other side, the excess heat or cold will be used in a district heating and cooling network for air conditioning the buildings.
Barcelona's Parc de l'Alba shows what can be done in terms of sustainable growth in a modern city. But the project is unusual.
I think one major problem is that we know in principle what the solutions are. The technological solutions are there, both for the buildings and also for the renewables. But nobody's doing it at a large scale, and this is mainly due to costs and a certain insecurity of whether it really will work. So we need large-scale demonstration projects where we can show that the technologies work, that they might be still a bit more expensive than conventional technology, but in the future, within 10 or 20 years, they will certainly pay off.
From energy-efficient office blocks to hydrogen buses, biomass plants to solar cells, the elements for healthy, clean and sustainable cities are within reach.
We are currently in a transition phase. The energy costs have gone up significantly during the last years, and everybody is becoming more aware that the fossil resources are limited. So now we are looking for very different ways of reducing the dependency on fossil fuels and to creating new ways of integrating renewables and significantly reducing our energy demand in the cities, both for buildings and transport.
There is a sense that these ideas are taking hold, but amidst all the other great challenges of city life, the energy question and the changes it may invoke has become paramount.